This video is for lesson 4.3a, solving multi-step equations. We're going to start off by just doing a quick review of solving equations by doing inverse operations, doing examples 1a and b. Remember that when we're solving an equation, all it really means is we want to isolate the variable, which means get the variable alone. And to solve, we need to make sure that we do the inverse operations of what's being done to the x, or to the variable in question. So for question A, I'll do this one fairly quickly because we've done examples of this before. If you look at x being multiplied and also there's 4 being taken away, so what that means is we need to do the opposite of those, and we do BEDMAS in reverse. So we're going to do 3x minus 4 plus 4 is the opposite of minus 4 is equal to 10 plus 4, and then we'll get 3x is equal to 14. And then we can do our division, which is the opposite of multiplication. So 3x divided by 3 is equal to 14 divided by 3. And we get x is equal to 14 over 3. We'll keep it as an improper fraction there, so remember your proper mathematical form. And that seems to be the simplest that we can get it to. So what I've done there is I've basically just isolated the variable by doing inverse operations. One thing that you might need to do sometimes is you might get an equation that looks something like this. And before you isolate the variable, you need to make sure you use your distributive property to simplify first and then solve. So it's always important to simplify first and then proceed to solving. So remember, you distribute the number at the front of the brackets here to all the terms within. So we get 3x plus 3, that I did 3 times x, and then I did 3 times 1 is equal to 12. And now I can proceed and solve for x like I did in the previous question. So I have 3x plus 3. The opposite of plus 3 is minus 3, so minus 3. And then I have to do the same thing on the other side, so 12 minus 3. And then I get 3x is equal to 9. And now we still have to divide by 3 to get rid of the 3 that's multiplying there. So 3 over 3, 9 over 3, to do the same thing on the right side. 3 over 3 cancels out because that's equal to 1, and so we get x is equal to 3. And if you're asked to verify, you can verify using a left side, right side table like we did in the previous lesson. So that was a quick review on how to solve for variables. You should be able to do that whether you're given a simple equation like this or an equation like this. Just make sure you use your distributive property before you proceed with solving. It's much easier. So now we're going to take a look at a way to think about equations. You can think of an equation almost like a machine. And what you can do is you can put something into that machine that's called an input. So for example, I might put x is equal to 2. I might put that into this machine here. And the machine is 2x plus 8. If I put x is equal to 2 into the machine 2x plus 8, I get an output, meaning what does my equation equal when I put x is equal to 2 in here? So an easy way to figure that out is by replacing the x value by 2. So I have 2 times 2 plus 8. And that's going to be equal to 10 plus 8, which is equal to 18. Here's another machine. It's just a different equation. I'm gonna put the same input in. I'm gonna put x is equal to 2, and see what my output is. What do I get? What do I get when I put x is equal to 2 into the 4x minus 18 machine? So I'm going to replace that x by 2. So I'm going to have 4 times 2 minus 18, which is going to be 8 minus 18, which will be minus 10. So those equations are two different machines, and for the same input I get a different output. But sometimes I might ask you, well, what value of x would give me the same output for both machines? And the easiest way to do that is to equate your equations. So in this example, what was done is we wrote that 2x plus 8 is equal to 4x minus 18. And if we solve for x, what you've done is you found the x value that makes these equations equal. So after this video, you can go back and you can try to find out what x value would make these two equations equal. To do that, to solve for a variable when you have variables on both sides of the equation, you have to follow the following steps. So use the inverse operations to group the variable terms on one side. So you want to put all the variables on only on one side, either all on the left or all on the right. So I want to get my x's either all on the left side or all on the right side. And we'll see how to do that. We use the inverse operations. And then we put our constants, so our non-variable terms, on the other side, on the opposite side of our variables. That way, we can now isolate our variables by continuing to use inverse operations. It'll be a lot more simple once we do some examples together. So we're going to try this example here together, example 2. I want you to get, we're still trying to solve what is x equal to make this true, to make this equality true. But the difference that this is compared to what we saw in the previous lessons is that we have variables on both sides of the equation. We have x on the left side and x on the right side as well. So I'm going to choose a side to put my variables onto. And it doesn't matter, you could have chosen left or right. I'm going to choose to have it on the left side. So I'm going to choose to get my 4x and move it over to the left side. So the way to do that is by using inverse operations. So I'm going to start off this way just to show you what I'm doing in my head. 4x is on the right side right now. To get rid of it, I need to do the opposite. I need to subtract it. I need to do 4x minus 18. And I need to do the same thing on the other side. 2x. Since I took away minus 4x from the right side, I'm going to take away minus 4x from the left side. Plus 8. And so 2x minus 4x is negative 2x. Plus 8 is equal to 4x minus 4x is just 0x, so that's gone, minus 18. So now what you've done is you've created an equation that you're kind of familiar with solving. You just have to do the inverse operations to isolate for your x and find its value. So I'm going to do minus 2x plus 8. The opposite of plus 8 is minus 8 is equal to minus 18 minus 8. And so I get minus 2x is equal to minus 26. And then I can do the opposite of a multiplication, which is a division. So divided by negative 2. I have to do the same thing on the other side and the right side here. Negative 2's cancel out because they're equal to 1. X is equal to negative 26 over negative 2. Remember, when you divide two negative signs, it becomes positive. So x is equal to 13. So that was the example that we saw above here with the machines. So you don't have to go back after the lesson to do it. It's already done there. But you can go back and retry if you'd like. You can plug them into the machine after the lesson and see if you get the same output value. So you can go into the machine here. You can put x is equal to 13 as an input and see what the output is. And then you can check over here x is equal to 13 as an input, and then check what the output is, and see if they're actually equal to each other. If they are, that means you did the right steps. So we'll try another example together. We'll do example 3a. So this time I'm going to collect all the variables on the right side. It doesn't really matter what side you choose, the answer will still come out to the same thing. I'm just going to show you a variation of this. So I'm going to get rid of the 3x from the left side and basically send it over to the right side. So to do that, I simply do 3x minus 3x plus 2 is equal to 2x. Now to get rid of the 3x on the other side, I have to do minus 3x, so I'm going to do the same thing here, minus 3x minus 4. And then I'm going to go and simplify. So 3x minus 3x is 0, so that's gone. So now I'm left with just that 2 there, the positive 2. I don't have to put a plus in the front because it's positive. If it was a negative, I would have to keep the negative there. Is equal to 2x minus 3x, which is minus x minus 4. And now I can solve and isolate for that x variable by doing inverse functions. So I need to get rid of the minus 4, so minus x minus 4 plus 4. That's the opposite of minus 4. And since I'm adding 4, I'm doing 4 plus 2 here. And so that's going to be 6 is equal to minus x. Minus 4 plus 4 is 0, so just minus x. Remember that we have minus x at this point. That means it's minus 1 times x. So I need to divide by minus 1 on both sides. And I get x is equal to negative 6. Because 6 divided by negative 1 is negative 6. This could have been done by sending the variable to the left side instead, and I'll quickly show you that before we do the other examples. So I have 3x plus 2 is equal to 2x minus 4. I'm going to send the variable to the left side this time, so I'll do 3x minus 2x plus 2 is equal to 2x minus 2x minus 4. I did minus 2x to get rid of the 2x from the right side, so it ended up on the left side. So that gives me 3x minus 2x is x plus 2, which is equal to 2x minus 2x is 0, so we just have minus 4 left. Now we can solve and isolate for x, so we have x plus 2 minus 2 is equal to minus 4 minus 2, just like I did on the left side. And I get x is equal to negative 6. So the process was a little bit different because I sent the variables to the opposite side. I didn't have to do the division in the end, since I sent my 2x to the left side instead of sending my 3x to the right side like I did here. But the end result is the same. You get x is equal to negative 6 regardless of which side you choose to send the variables to. So in the next video, I'm going to go through examples B, C, D, and E with you. You can try them out yourself first. And then after that, we're going to just do an example to see how to check if our solution is correct using a left and right side table like we did before. And then you'll have all the skills necessary to solve some multi-step equations that don't include fractions.